Welcome to another episode of 3-Minute Videos with Nathaniel. Today we are now going to look at question 1D of MAT Oxford 2020. The question asks to find the maximum value of this polynomial. Look, sin x, cos square x. What are we going to do with this cos square x? Luckily for us, there is one simple identity, which is short for algebraic expression, where you can simplify stuff that turns out to turn a cos squared into a sine squared. The identity is sine squared x plus cos squared x equals to 1. We'll box this identity up because it's so important. Now, we need to make cos squared x the subject. What we can do is move sine squared x to the other side. Remember to switch its sign to become cos squared x equals to 1 minus sine squared x. We can substitute cos x for this expression in here. So 1 minus sine squared x plus 2 sine x plus 1. Do you know what is sine squared? Sine squared x equals to sine x squared. So it's basically sine x but squared. Now we have a quadratic polynomial in terms of sine x, which means it's a polynomial of degree 2, but instead of making x the variable, we make sine x the variable. Now what we do is that we can put the number and multiply it with the expression in the parentheses. Remember to multiply the number here by all the terms in here. As per normal. And we group the similar terms together. Notice the constant term at both the beginning and the end. We group them. You see why this simplification is necessary. Now look at this. Since it is sine x squared, this same expression can be written as minus 3 sine x plus 2 sine x plus 4. To find the maximum value, we need to find stationary points. And to find the stationary points, we need to find its gradient. Its gradient can be derived by using dy over dx. Now we're starting to get the pattern here. A lot of terms and equations which involve change, stationary points, gradients, or tangents, we need this. Now we can simplify and derive this. This becomes 2 cos x. The derivative of sine x is cos x. And well, to remember that, because I'm going to write it here. And we box it up as per normal. And what's the case with constant terms? They plunge into the abyss and remain nothing in this. This is what makes use of a product rule. The product rule is minus 3. So what I commonly use is the CD plus DC method. Basically, since both these two functions are the same, we can simplify it into minus 3 to CD, but we will not write that here. We will write that in the next step. As we've seen, the derivative of sine x is cos x. It's minus 3 to sine x cos x plus 2 cos x. Now we can take away a common factor of cos x. Cos x equals to 0 or minus 6 sine x. See what I did there? Minus 3 times 2 is 6 plus 2 equals to 0. Now let's move on to the other side of the board. Minus 6 sine x plus 2 equals to 0. Notice why I neglected the cos x, because it's not needed and all of the options are rational values. Sine x equals to minus 2. Minus 6 is still here. Sine x equals to minus 2 over minus 6 equals to 1 over 3. Because we take away minus 2 in each. X equals to sine inverse 1 over 3. At this point, you had the guts to reach out your calculator, but no. You see why we did the simplification here? It is because we can make sine inverse 1/3. Now let's introduce you a new trigonometry identity. Sine on the sine inverse of any number at all equals that number. You might think that's magic, but that's maths. Now let's go back to the original equation. We write it down here. Then we'll substitute sine inverse 1/3. That's quite a formidable equation. Then we simplify using the identity that I just showed. Now we put the square. See what I did there? I simplified minus 3 over 9 to become minus 1 over 3. And I also put the minus 3 inside the bracket. Now we will add these terms together. Remember our rule for adding fractions, make them the same denominator. Cos 4 is 12 over 3 is 13 over 3. Which is option C. This is a polynomial equation of degree 2 in sine x, very appropriately disguised to confuse all of you. Now, to find the maximum value isn't an easy job. It may be an easy job for all you maths geniuses out there, but to all you who don't know about it, it's quite an interesting job and it requires the use of a derivative. I think you can Google it if you like. See you! Bye!